start with the KFC case. It talks about certain operations in KFC, what are the people who work there, how the things are developed to create different kind of products which are sold. So you have to read this case carefully before you start preparing the ERD and preparing the star schema from it. So the first thing that we do is try to come up with a list of entities, and we start with that. So the possible list of entities I have noted down here. It starts with the name of the restaurant, the customers, the walk-in customers, customers for delivery, products, gravy, salad, order, complaint, team, store manager, assistant store manager, CSA, customer service agent, driver, inventory, order, item, cooked item, uncooked item, headquarter, daily report, transaction, sales, customer, address, cash register, cash, bank, and debit card. So as you can see, the list is pretty long, and definitely some of them would have to be excluded, and we can do one at a time. We can exclude these. We have no reason to model KFC restaurant because we are trying to model only one restaurant and see what are the main concepts within that KFC restaurants. We don't need to model gravy and salad because they are a type of products which are being sold. We probably don't need to model team as well because we are talking about individual people here. Report, daily report. Daily report again is a report. So report is a set of information. Information is generally not modeled as an entity. The reason is the daily report consists of information about inventory, sales, stuff like that. So we can collect that by combining certain tables. So report are generally not included as entity. Transactions, will not use transactions because we will rather use some kind of attributes inside sales to capture the notion of transaction. Customer address, again, it's an actually entity attribute. It is not an entity. Similarly, cash register can be considered as an entity, but there is not much meaning here because we really don't want to analyze something by cash register. Cash and debit cards are type of payments, so probably we'll go somewhere else and will not be modeled here. So we need to talk about the scope of the model here. The scope of the model is only capturing the important concepts, not each and every concept that can be potentially termed as an entity. So that's why I ignored cash register, I ignored team, I ignored different kinds of products, and try to make it as concise as possible. Okay, we can see that there are two kinds of customers very clearly because some would just walk in and some would just call from home and they would like the products to be delivered to their location. So again, we need at least one attribute which is different from this so that we can create subtyping. So for walk-in customers, wait time is an important information. How long they have to wait after they place their order so that the product can be delivered to them. Similarly, delivery address or phone number is important. Another subtyping that could be important in this particular case is the item, because you see there are quite a few items and some of them have been cooked or some of them are not cooked. So if they are not cooked, they have a date of expiry. For example, if I have, let's say, some kind of frozen, let's say, just sauces or some barbecue sauce, something like that, that will have some expiry date. Whereas something which is being cooked, let's say fries, will have some expiry time. You cannot reuse a fry after 6 hours or 8 hours or whatever the time frame would be. One important distinction that we have to make is the distinction between item and products. Item are the raw materials that are combined and sold as a product. So customers don't buy items, customers buy product. KFC makes revenue by selling products. Items are used to make products. So items are very important for them because they have to be supplied by suppliers. And that, by the way, I think I've not used suppliers here in this list. It should be added as well. So So it is important to distinguish item and product because item will have different types, including raw materials, cooked, uncooked, and they will finally end up as a product which is being purchased. So product and item distinction is important. All the relationship, all the entities that we spoke are written in the above stage. We need to find out the relationship and then develop the model. There is also a possibility of alternate model, which I'll talk a little bit later. Now, let's go and look at the ER model that I have created based on this information, and then we will analyze. So as shown here, I have already talked about this part: customer, phone number, phone customer, walk-in customer. We already talked about item, cooked item. We already talked about an important relationship between product and item. So product is composed of items, and this is very important. So item is also related to item order, and item order is related to supplier, item is related to inventory. So you see that this part, supplier, inventory, item order, item, they are all related to items and products. Product is cooked by cook, then sales is managed by assistant manager, the deposit to the bank, assistant manager reports to the headquarter, inventory is managed by manager. This is one of the key role of the manager, is to manage inventory. So we can see the differences. We also have a CSA, which is customer service agent, and we need to distinguish customer service agent from the rest of the employees. So we have something called communication skills. Now you might wonder, how do I model it? How do I use it? As a database, if it is a database, we can say that communication skills could be high, medium, and low. So if you have a high communication skills, probably would have a very high customer satisfaction or less wait time, something like that. Driver, in order to distinguish between other employees, I have the driver license as an attribute. Sales, transaction ID. Every time a customer comes or places an order, there has to be a unique ID called transaction ID. Based on that, it will be possible to identify who placed the order, what was the order, what product was given, when was it ordered, things like that. So that's why you have the time, sales time, discount, what was the discount provided, how much was the amount. So and also you note that customer can also make a complaint, which is processed by CSA. So we have considered all the concepts. One important concept is order. Now it is important to distinguish between order and product. Order is a concept. Order is a concept because it's not a physical product. It is information about what products to be prepared. So it is not the product itself. So you, based on certain order, you create a product. So it has to be clear that order is different from product and product is different from item. You use item to make product. You use the information of order to know what product to make. So all these three are related, but they are very distinct. So I hope you have understood the concept of it. Item, if we have item, we also need to keep track of the inventory, how much item is left, because this is crucial. If certain inventory is low, it has to be ordered, reordered, and at any point of time, a manager should know what is the quantity on hand of all the items which are there in the store. Okay, so from here, how do we create the star schema? And as I told you, we have to do certain things. First thing is we will remove all the relationships. We will focus on certain aspects, probably remove some of the entities and try to combine them. For example, we can combine all the customers in one place, all items, item order in one place. Okay, probably it also makes sense to combine all the employees in one place, CSA, assistant manager. By the way, if you recall, I told earlier that there is another way, alternate way of developing this, and that would be to create a generic entity called employee, and we will have employee ID and employee number, and then each subtype will have, let's say, manager, assistant manager,